Hi, we're going to wrap up 2.3 in this video. We're going to look at gravity problems, or just one of them actually. This is going to model, or this equation here is going to model the position of a falling object, or an object that's under the influence of gravity. That equation is h equals -1/2 gt squared plus v naught t plus h naught. Now there's a lot of stuff going on in this equation. Let me break it down and go through each part. H is the height of the object at time t. So given a t, we'll plug in the t and we'll get an h back that gives us the height of the object. G is the force or acceleration due to gravity. So if we're dealing with feet, we want 32 feet per second squared. If we're dealing in meters, 9.8 meters per second squared. That'll come from the context of the problem as to which one you use in for G. T is, of course, time. V naught is the initial velocity of the object, so at time equal to 0, that would be the number that you put in here. The naught is just a subscript. It indicates that it's at the time equal to 0, velocity for the time equal to 0. H naught, same thing. This would be the initial position of the object. How high is it when we start the clock, so to speak. Okay, so this is just a quadratic equation of a single variable. The variable here is t for time, and then we solve those as we did in the previous videos, the previous techniques in this section. So here's an applied problem. Let's go ahead and work through this. So we've got a rock and it's thrown upwards with an initial velocity of 24 meters per second. So our initial velocity from the top of a 21 meter high cliff, and it misses the cliff on the way back down. That would be important. The question is, when will the rock be 7 meters from the water below? And then we want to round to 2 decimal places. Okay, let's go through this again and pull out the relevant information. So we know the rock is thrown upwards with a velocity of 24 meters per second. So that's our V naught right away, 24 meters per second. It also tells us something else, and that we're going to be measuring the distance in meters. So when we set up this equation, we're going to want to make sure that we use this 9.8 meters per second squared for G. All right. So this is thrown from the top of a 21 meter high cliff. That's going to be H naught. And it misses the cliff on the way back down. So let's draw just a picture here. So we've got the cliff, and there's the water below. Water there. We know something about this. We know the height here is 21 meters. And we've got a rock here, and we're going to drop it, so it's going to fall. It's got some, first off, we're going to throw it up with this 24 meters per second. So it's going to gain some height, and it's going to start to fall. And we're interested in the time when it is 7 meters above the ground. So I'll go ahead and put on dashed line here. Call that 7 meters. Right? And that's the point we're interested in, right there. All right. So this is going to be some height, and we are asked to find when. So we're looking for a time. All right. So let's go ahead and set up this equation. We don't know what the time is, so we'll leave that as t. We have all the other pieces of information, though. We want to know when it hits 7 meters. We have -1/2. We want to choose the correct G, 9.8. T squared. And we have plus V naught, which is 24. So 24 T, and then plus H naught, which is 21. So this is a quadratic equation, single variable, and we can solve that usually using the quadratic formula. So here we have, we're going to subtract the 7. We get 0 equals, we'll go ahead and combine this, negative 4.9 t squared plus 24t plus 14. All right. So here we want to use the quadratic formula with a equal to negative 4.9, b equal to 24, and c equal to 14. So go ahead and, if you got your calculator, go ahead and write out the quadratic formula for this, and then type it in. You'll get 2 answers. So go ahead and pause the video, and then come back. Okay, you should have gotten 2 answers. So the first answer, 5.42465, and so on. That approximately equal to, and t approximately equal to negative 0.526696. Okay, now only one of these answers makes sense for the problem. T equal to 0 is when we start to throw the rock, and then sometime later, right, we will have the height be equal to 7 meters. That's going to be this first one. Where does this negative one come from? Well, since this is a quadratic, it's going to have 2 solutions. It's going to have 2 real solutions. If you calculated the determinant, you saw it was positive. Right? This would happen before the rock is thrown. So that would be, if we say this fictional period of time here, I'll put that in quotes, this is not part of the actual model of this rock. We do not know what happened to this rock. It was kicked off the edge or kicked up in the air or something. Anyway, what happened before it cannot be modeled by this equation. Okay, so this is out. This is our answer. We're asked to round to 2 decimal places. So we'll look at the second decimal place. It's a 4. I'm sorry, it's a 2. The one next to it is 4. 4 is less than 5, so we just round to 5.42. So the time it takes to reach this rock to reach 7 meters above the water, it takes 5.42